Myself, Dr. Mangala Kandagal, Assistant Professor, Department of PG Studies and Research in Mathematics, Faculty of Science and Technology, Sharnbasva University Kalaburagi. My presentation topic is effect of two immersible multi-fluid flow on internal heat generation or absorption a vertical channel in the presence of concentration. Objectives of my paper is introduction, mathematical formulation, resultant discussion, conclusion, and references. Objective. In this paper, we investigated the effect of heat mass transfer of multi-fluid flow characteristics in vertical channels. The fluids are incompressible in both the regions and assume that transfer properties are constant. The basic equation governing the flow consists a set of coupled nonlinear ordinary differential equations solved by using analytically by regular perturbation method. These results are illustrated graphically and also discussed the effect of physical parameters such as Grashof number, viscosity ratio, width ratio, thermal conductivity ratio, and thermal expansion and concentration expansion coefficients. Here we can control results by heat absorption and heat generation coefficients, width ratio, and viscosity ratios. Introduction. The derivative of convection motion by a boundary layer including heat and mass transfer in pad surface can be implemented in many engineering and geophysics problems. Hence, the objective of paper is to consider the problem of flow and heat transfer and heat generating or absorbing of immersible fluids in vertical infinitely long channel with concentration. Mathematical formulations. This figure one is a physical configuration. This figure consisting of two parallel plates maintained at a different constant temperatures. This region 1 Y lies between 0 to H and occupied by viscous fluids of density ρ1, viscosity μ1 and thermal conductivity K1. Then this is region 2. This Y lies between minus H2 0 and this another fluid of density ρ2, viscosity μ2 and thermal conductivity K2. Here we assumed that the fluid heat absorption or generation have a constant properties accepting the density in the buoyancy terms. In the momentum equations, the fluids in the channel rises is derived by buoyancy and both the fluids are assumed to be a constant in the transport properties. These are the governing equations of velocity, reason 1 and reason 2. In reason 1, 2.1 is the law of conservation of momentum equation and 2.2 is the energy equation and 2.3 is the concentration equation. Similarly, in reason 2, these are the boundary and interface conditions. 2.7a to 2.7d is the boundary and interface condition on velocity and 2.8a to 2.8d is the boundary and interface condition on temperature and 2.9a to 2.9d is the boundary and interface condition on concentration. This 2.9 is the governing equations of non-dimensional and substituting this 2.9 in 2.1 to 2.5 we get the dimensionless equations of reason 1 and reason 2. Reason 1 is 2.10 to 2.12 and reason 2 is 2.13 to 2.15. These are the non-dimensional form of velocity and temperature boundary and interface conditions. Substituting those conditions, we get the solutions of this concentration. Psi1 and Psi2 are the concentration solutions. Here we have the two cases. One is heat generation case, another one is the heat absorption case. In heat generation case, we get the two solutions, zeroth order solution and first order solution. These are the zeroth order equations and these are the first order equations. Similarly, we get the heat absorption case. Here also we have two solutions of equations, zeroth order solutions and first order solutions. These are the zeroth order equations and these are the first order equations. Resultant discussion. Figure 2 shows the velocity profile for different values of Grashof number. Here the Grashof number is increases, the velocity is increases. Increasing the Grashof number physically, which means increasing the buoyancy force which supports the flow, And figure 3 shows the velocity profile for different values of viscosity ratio m. Here the viscosity ratio m is increases the velocity profile. The value of m0 0.01 when the velocity of the fluid in region 2 is 100 times the velocity of the fluid in region 1. Figure 4 and figure 7 shows the velocity and temperature profile for the different values of width ratio h. Here width ratio h is increases, both velocity and temperature is increases. This figure 5 and 8 shows the velocity and temperature profile for different values of thermal conductivity K. Here the thermal conductivity K is increases, both velocity and temperature is increases. Then figure 6 and 9 shows the velocity and temperature profile for the heat generation coefficient phi. So here we considering phi 1, phi 2 is equal to phi for the simplification. Here the heat generation coefficient phi is increases, both velocity and temperature is also increases. Then figure 10 and figure 11 shows the velocity and temperature profile for the different values of heat absorption coefficient phi. So here the heat absorption coefficient phi is increases, both velocity and temperature is decreases. Then figure 12 shows the concentration profile for the different values of diffusion coefficient ratio D. Here the diffusion coefficient is increases, the concentration profile is decreases. Then figure 13 shows the concentration profile for the different values of width ratio H. So width ratio H is increases the flow speed. Conclusion. The problem of steady heat and mass transfer of two fluids in vertical channel with symmetric wall temperature in the presence of free convection current was analyzed with a concentrations. Analytically, we solved the dimensionless momentum and energy equation for velocity and temperature profiles. It was observed that the presence of buoyancy force and heat generation announced the flow rate in the channel, while the opposite is true for the heat absorption case also. The flow in both the regions were announced by increasing in the velocity ratio, width ratio, thermal conductivity ratio, and diffusion coefficients ratio. Finally, we conclude viscosity, width of the channel, source and sink control the heat absorption and momentum transfer. These are the references I used to solve my paper. And this is my research publications, research kit, Orchid ID and Scopus ID.